So in this question here, I've got a ball of mass 20 kilos suspended from a ceiling by two ropes, rope A and rope B. Now, rope A makes an angle to the roof of 30 degrees. Rope B makes an angle of 45 degrees to the roof. What we want to do is calculate the tension in both ropes. So first of all, where's the tension and what direction is it going in? Well, the ball of mass 20 kilos is hanged by two ropes. This force will come down as 20 times the force of gravity. So as the force is coming down, there must be an equal and opposite reaction, which will come from the tension in the ropes. So that'll be going in the opposite direction. So they'll be going in the upwards direction, but at different angles. Now I've got my angles here, which are 30 degrees. This one here is 45 degrees. And one other thing we need to talk about is G, which is my gravitational constant, which is due to gravity. So G equals 9.81 meters per second squared. For our calculation, we'll just use the 9.81 in this question. Now with this particular question here, I'm going to show you guys two ways how to solve this. Then you can leave in the comments which way you prefer. And it's up to you which way you want to go. Both will give you exactly the same answer. So first of all, I'm going to list up my forces. So I'm going to draw a little triangle and turn it into a little trigonometry puzzle, and then I can go from there. So if I do that representing the roof, and that one there, and that rope there. So that's my rope A, that's my rope B. This is my weight. Then I've got my angles 30 degrees and 45. So all of these kind of questions are almost like trigonometry puzzles. So then I will draw a nice little perpendicular line to the roof and create a right angle triangle. And then we can use all our general rules of SOHCAHTOA. So now what do I do next? Well, I've got forces going in my tension, which will pull down and a little bit across. So as this ball here is in equilibrium, it's not moving. Therefore, the forces are all equal. So the forces going in this direction would equal the forces going in this direction. And same here. The forces going downwards will equal the forces going upwards. Otherwise, the thing would be moving. So now, let's calculate my forces. So let's resolve horizontally. So what I've got here, I've got this force here. That will be an horizontal force. And it would be equal to this one, so I'll call them both F, that will be legitimate. So they'll be set equal, otherwise the thing would be moving. So here, this force will be pulling in, this one would also be pulling in. Okay, now what have we got here now? So we could use 30 degrees and it's the adjacent side. So here, adjacent, we use cosine. So if I say cosine of 30 degrees equals my force here, that's my adjacent, and my hypotenuse, well, my hypotenuse is just my tension A. So here I've got A. So then to work out what that force is, I've got the force equals A cosine of 30. And then the other force, which will be equal to that, I'll just do the same on this triangle, in which case I just have cosine 45 equals force over B, in which case force equals B cosine 45. So then I can write these up here as they are equal to each other in this manner here. So I've got A cosine 30 equals B cosine 45. And that works for my horizontal forces. Now what about my vertical forces? So resolving in the, let's go in the downward direction, doesn't really matter, it all works out the same. So my vertical forces, so here I've got to look at this bit here. So I've got a force there, these two forces be very identical, and I've got the weight pulling down, which is my 20G. So these two forces here will equal this force here. So let's work out how to do that. So the ones pulling down will equal the ones pushing up. So here, as I've got my 30 degrees, this is opposite, so we'll be on to the sine. So then I've got sine 30 equals my force F over A. So then I'll have my force equals sine 30 times A. Let's just write it like that. And then for the other one, I'll have the same but with a 45-degree angle. Sine 45 equals the force over B, in which case my force will equal sine 45 times B. Now the sum of these two angles will equal the mass of my ball hanging downwards. So I'll have to multiply that by the gravitational constant. So if I write that as a different equation, a bit different to the start of this one, I'll need this one plus this one will equal that. So let's just list them as force 1 and force 2. So I've got force 1 plus force 2 equals 20G. Okay, so force 1 is sine 30 times A. So I've got A sine 30. And then let's add that to this one here, which is B sine 45. And that equals 20G. Okay, so now I've got two equations. I've got equation 1 here, equation 2 here. So I need to solve those. Now, two equations with two unknowns, usually simultaneous equations. But here, that's going to be a bit awkward with these. So what I'm going to do is, I'm going to do a substitution. So if I isolate an A and a B from here, and then plug in accordingly to solve for A and a B. So if I get my A isolated on here, so I'll have A equals, divide both sides by cosine 30. So A is simply B cosine 45 over cosine 30. And likewise for the B, set my B, that will equal A cosine 30, and then divide by cosine 45. That will take care of that. And then I can substitute accordingly into this one to solve for A or for B. So first of all, let's substitute in for A, and then I will get all B's on both sides of this equation into equation 2. So A is simply B cosine 45. So let's write that there. B cosine 45 over cosine 30. And then I need to multiply by sine 30. Don't forget the sine 30. And then plus B sine 45. And that equals 20G. So that takes care of that. So now let's factor out and isolate the B on its own. So then I've got B cosine 45. Now here I could do a little shortcut. I've got sine 30 over cosine 30, because I could extend this divide here, which is just tangent 30. And then plus here, factoring out the B, I've got sine 45. And that equals 20G. Okay, close off the bracket. Now isolate the B, divide both sides by this, and then I'll get B equals 20G. Well, let's put in my gravitational constant at this stage, 9.81. It's always good to leave all your calculations to the end. That way then you don't get any rounding errors. So cosine 45 tan 30. Multiplied, and then add sine 45. And that, plug it into your calculator, you should get 175.9 approximately. But we'll call it 175.9 for now, and that will be in newtons. As I've got my mass times my gravitational constant, I'm happy now to put newtons. So now let's solve for A. So I'll substitute in for B into here. So I've got A sine 30 plus, now what's my B? B is A cosine 30 over cosine 45. And then again, not forgetting the sine 45. So easy to forget the sine 45. And that equals 20G. So all good. It's looking good now. So now we do the same as we did here, isolate the A and then divide both sides. So then we'll come to A sine 30 plus cosine 30, and again we've got the tangent arriving here. You should always have a tangent in this, so if you haven't, you've probably gone wrong somewhere. So that one there equals 20g, and we know tan 45 is actually 1, so at this stage we could actually eliminate that if we wanted, but I'm going to put it in there anyway. So we've got all the calculations in there. 20g, let's put the 9.81 like we did there, so 29.81 divided by sine 30 plus cosine 30 tan 45, and then plug that into your calculator. A should come out to be approximately 143.6. And again, happy with newtons, because I've got my mass and my gravitational constant together. So that's my A and my B force using this technique. Now I'm going to show you another technique after clearing the board. Okay, so now that's all cleared, now I'm going to show you a second way of how to do this. So now what I'm going to do is I'm going to set up a triangle a little bit different. So this force coming down, I'm just going to draw a nice straight line there to represent that. And then using a kinetic diagram with my vectors, treating these forces as vectors, I'll have my B going in this direction and my A going in this direction. Now as it's in equilibrium again, we can join these all together. So then I've got 20g, and then I've got to work out what my angles are. So if I just draw a parallel line, these lines are parallel. Don't get that confused with the tension. That's just to represent parallel lines. So that's 20g. And then I've got this one here which represents my A. So this angle here would be 30 degrees. And then with this one, this angle here would be 45 degrees. Okay, so let's put 45 degrees. And then what I've got now, I need to work out what the angles this side are, which looks pretty straightforward, as this would make a right angle. I've got 45 there and 60 there. And all the angles in a triangle are 180, so nice and straightforward. That one would be 75 degrees. Now let's just label these up so we know what we've got. So that's B and that's A. So now what we need to do is we need to solve for A and B. But we've got this one here, which is 20 times 9.81. So what we've got here is simply a diagram which can be solved using the sine rule. So 20g, so do that one with 75. So I've got sine 75 over 20g. Now these should all work out equal with their opposite sides. So now I've got, let's do this 45 in A. So I've got sine 45 over A. And then this one, I've got sine 60 over B. So by the sine rule, they should all be equal, and it's fully legitimate as it's in equilibrium. So all these forces can be connected to one triangle. So now I can simply solve for A and B by using this ratio here. So if I do A with this one, so I've got, let's just do the algebra carefully so we don't mess it up. So that's sine 45 over A. So times both sides by A and times both sides by 20g. So then I'll have A sine 75 equals 20g sine 45. And then isolate the A because 20g is just a number multiplied by 9.81. So I've got A equals 20g sine 45, and that's divided by sine 75. So that's what will be representative of my A. So now let's do the B over here. So same thing again. If that's all multiplied and shared out and everything, we should end up with a similar situation. Except for the sine 45 here, we'll have a sine 60 here. So then we'll have B. That would equal 20g sine 60. So you can see in this case that would end up over there. and then the sine 75 will end up there and the b will end up back there. Okay, so plug those into our calculator and you'll see that A comes out to be 143.6 newtons. As we got a G and a mass, I'm happy with newtons. And then B would equal 175.9 newtons. And you'll see that these were exactly the same answers as we got in the previous method. So I do love it when maths has more than one method to get to our result. So in this case, we've got those two coming out identical to the other method, which is as they should be. So there we go. So you can leave a comment in the comments below and tell me which method you prefer, and maybe you've got a third or even a fourth method. So I'd like to hear from that. Thank you.